Good afternoon, everyone. It's now already 2:34 p.m. We shall start our session. I would like to welcome everyone to PCSS Planning, Scheduling, Controlling free webinar. Thank you very much for your participation today. Here I would like to say something about the construction and planning. Construction, planning, and scheduling are key aspects in integrating all your construction activities and phases needed to complete a given construction project at a given budget and time frame. Although having individual functions, planning and scheduling are inseparable when it comes to successful project management. Okay, to be successful with your construction project, careful planning is needed to create a schedule that will allow you to deliver your project on time and within budget. Both construction planning and scheduling take a lot of time to create and implement, but the time that you will save during the actual work will be more than the time you spend creating your plan and schedule. Okay, at this webinar session, you will be introduced to the planning, scheduling, and controlling phase of a project. And then the speaker for today is our Mr. Bian Mutang Tagal. He's a senior planner, which is currently based in Miri for WPC 11 Pen Borneo project.
Okay. Thank you, Flora. Can you hear me fine? Flora, are you able to hear me?
Yes.
Okay.
With this, I would like to invite Mr. Bian to begin our session today.
Okay, just doing a simple sound check. So thank you. I would like to thank everyone for being here today, for taking the opportunity, take an hour out of your session for today to join us. So without further ado, let us get started. All right. What are the reasons for planning? Planning is a normal aspect in our life. It's not just relegated for any person or just for your workplace. In fact, we do planning in our daily routines. When we wake up, when we think what are we going to eat, when we plan what we're going to buy, those are planning. But what are the reasons for planning? We do it because we want to make a decisions. So we have a decision-making process to make. Sometimes if you are a team lead in your team, you need to delegate. So planning is a basis for delegation. It's also a basis for control and a basis for communication. All right. So what does a good project plan answer? What needs to be done? So the simplest way for professionals to think about this is to see what is to be done. So we think about the scope. What are the scope of work that needs to be done? When will it be done? What are the timeline that's given to complete it? And who will do it? Who is responsible for it? How many resources to do it? How long it'll take, which is the duration, how much, and how will it be controlled? So you can see that there are many questions that has to be answered in a plan. What are some excuses for not planning? Sometimes we just don't want to plan. That is human nature. We just want to go with the flow. But as we know, if you don't plan, you are basically planning to fail, especially if you're in a project setting. Sometimes people say that it takes time or plans, they're always wrong. When I do it the first time and then it changes, things change and it's not applicable anymore. Or plans are hard to maintain and it stops me from getting on with my work. I just want to sit down in my computer and, just do all my work without having to worry about a plan. It's a commitment. It needs discipline. But those are not really valid excuses. Those are not valid excuses for not having a plan. All right. Okay. And what are some planning issues, common planning issues that we face? Sometimes the scope definition. I think many professionals here in your industries, you have an issue with this. The project owner issues a scope in the beginning of the project, and then throughout the project, you see scope creep, which is where additional scope comes in, and then it becomes a hassle to manage it. Okay. Sometimes we have to plan for contingencies. We don't know when the weather, when it will be a bad weather, and that will prevent us from doing our jobs. Okay. So what exactly is a project? So the attributes of a project, according to the PMI, is a project is a unique one-off discrete undertaking. A project is a temporary endeavor with a finite duration. So that means routine jobs, repetitive jobs are not really considered a project. A project always brings about change. A project will utilize resources. A project will have a budget, and it has a distinctive and unique life cycle. I like to use this post that I found on LinkedIn to reinforce what I've been thinking, my points about planning. He decided to remain anonymous, so I'll just read his post here. As I gain work experience, I keep learning and adapt. I still consider myself a junior. Along the way, I found out that sometimes I can lose motivation. In early days, I was someone who think technical is everything, planning and management is such a headache. But at some point, I learned that I'm wrong. Later, I believe one crucial part of project execution is the initial planning itself, which I love practicing it till today. I learn from my senior and adapt their work style. I would love to keep remind myself and also the team to focus on small objectives so that we can keep the motivation to get the work done, whether for my company project or my own small scale personal project. So what he just said sums up what planning is. And this is on a personal level, he feels it that is necessary for his professional growth and his personal growth too. So I would like to emphasize this point that planning is not just for X industry, okay? It's not just for the oil and gas construction, for the IT. It could be used in all industries. And it's not just for Y person, it's not just for the planner, it's not just for the project manager. The site supervisor also needs to do planning on his own, okay? All right. And next, we move on to the project management life cycle. This is a 5 phases of a project life cycle. You have the initiating process, the planning process, and the executing process. And controlling followed by the closing process. So for the purpose of this webinar, we'll just be focusing on the planning process, executing process, and the control and monitoring process. So that's the one that I've circled here. All right, so we see in more detail. We start out with planning. First, we need to define the scope. What is the scope that has been defined by the project owner? And then we need to define the activities, and we need to sequence them according to the activity relationships. Next, we need to estimate the duration, and then we resource load the schedule, the project schedule, with manpower, machinery, or the project resources. Okay, so this takes up a huge chunk of your time in a project, but the common adage goes, do it right the first time, okay, to save yourself a lot of problems later on. Next up, we move to scheduling. Then you start scheduling your plan using the CPM, which is one of the methods we use to optimize our schedule. And then we do resource leveling, another optimization method. And finally, when we're satisfied with everything, we've obtained the approval of the project owners, that is when we do the baselining. And once a baseline has been approved, then we can update the schedule and we can do performance reporting. So that falls under controlling and monitoring. Now, if you might see here at the end, there's scope changes right here. So that's why I mentioned in the beginning, you have to define your scope well in the beginning of the project. Otherwise, you will not be able to monitor scope creep. You'll not be able to have a case against the project owner if he introduces more scope creep. So it has to be decided early on in the project how to manage additional scopes. The planning phase is divided into one, scope definition, activity definition, and then sequencing, estimating the durations, and resource loading. Right. Scope definition. What is scope definition and what is the objective of this section? So project management involves the management of the core objectives of time, cost, and quality. You might have heard of it, the triple constraints, time, cost, and quality. Of course, there are other considerations. There are also resources, there's also communication, but the main ones that affect projects are time, cost, and quality. So these 3 elements are explicitly linked, and a change in one will affect the others. So this is important to us because it let us know that in a project, which element is being focused on, which element are the objectives of the project owner. Is he focusing on quality? If it's focusing quality alone, there'll be a trade-off in terms of cost or time. It may take longer to complete. It may cost more money, right? And if he wants it to be equal priority and quality and cost, then it may be difficult to complete on time. And similarly, if he chooses to prioritize time to complete it on time and at a reasonable cost, then quality might be a trade-off there. So these are the triple constraints that an organization, a project team has to look at and has to answer. Continuing on, how do we define our scope? First, you must gather requirements from your stakeholders. Contrary to popular beliefs, stakeholders are not only your CEOs, are not only your project owners. They are basically everyone who has an impact, who is receiving an impact from a project. So let's say in a road construction project, even the people living, even the villagers that live on the side of the road, which the government wants to expand the road in, they are also stakeholders because they are impacted by the project. But at this stage, scope definition is usually done by the project team. Okay. And next up, we'll also define the scope. How do you define the scope? You will have your deliverables provided to you. You have your bill of quantities, project exclusions and constraints. For example, your client might have specified a completion date. Or for construction projects, they might let you know that, hey, we haven't land and survey department, they have not released all the land yet in this entire chainage. So they may take some time and they may want you to build this into your schedule. So all this affects your scope. And finally, you have to develop your work breakdown structure. What is a work breakdown structure? A work breakdown structure is basically a way for us to decompose our project scope into more manageable units. So you can have multiple levels of work breakdown structure. Okay. So an example of work breakdown structure in Primavera P6 is this right here. And this is a simple work breakdown structure that's in use. And what you can see is that it comprises all the major phases: project management, preliminaries and general, procurement, offsite fabrication, construction, and commissioning. It's good practice to try to include all phases in your WBS. Sometimes in projects, we only include the construction and commissioning, and we leave out procurement and fabrication. Now that may become a really big issue if your organization does not have its own procurement schedule. Maybe it has one in Excel format somewhere, but even then, it's best practice to integrate it with your schedule. But it's not without its difficulties. So it's an ongoing process, it's a learning process, how to get better at it. On the right-hand side is also a work breakdown structure typically used in a construction industry. But this one, as you can see, is more detailed. So they go down into, for example, if I go to engineering activities, there's a method statements and the material submittals approval. So it's really detailed. If you look at the construction, it's organized. It's saying, okay, part 1 is from chainage 0 to chainage 20,000, and the part 2 is from chainage 20,000, and so on and so forth. And the level of details it goes to, it divides into concrete structures and then type of culverts, box culverts, and maybe down there will be the pipe culverts, and even down to the type of culverts. So it depends on your project organization, on your project owner, project team, how they want the WBS to be. Okay, but I like to use this example. Back when I was in oil and gas industry, I was stationed offshore once, and I remember it was my first job probably as a planning engineer. Previously, I came in as a graduate engineer, so I had done my schedule. I was very proud of it. It was like my first baby and everything. So I came in, and if you see behind the gentleman playing the guitar, you'll see on a notice board. That's where we normally paste the schedule. So I'll take my A3 pieces of work schedule, work program, and I'll paste it on the board. And then what happens is the moment I paste it, the supervisors come in. And first of all, the hot work supervisor comes in and says, hey, where, he says in Malay, where is the job that I'm supposed to do? And then next comes in the scaffolding supervisor, and he says the same thing. And then the E&I supervisor comes in, and I realized that I made a mistake because previously they have been accustomed to seeing the work program with the WBS broken down into disciplines. So they're able to easily see what jobs they need to do by discipline level. Whereas I had not. I'd done my WBS another way. I'd immediately gone down into the different decks of the platforms and the platforms, yes. So they weren't able to see the information readily. So what I had to do, I had to go back and to reprint everything. So this is just another reminder that when you create your WS, do it intelligently, and especially do it with considerations for the end user. You, the project planner, you are not the end user. The end user are the site supervisors and the site supervisors and the tradesmen that will be using it on site. Okay, this is just from my for speaking from experience. All right, and finally, once your work breakdown structure, you have to remember that you need to verify the scope. And this happens throughout the project, not just at the end. So throughout the project, you have scope that will be completed. So you need to gain formal acceptance of your deliverables because they will form the baseline against which all change requests are measured. So make sure you get the stakeholders to agree on the scope so that in the future, when there are change requests, you can compare it against a baseline. And finally, you have to control the scope too. So an organization in a project has to have a change control process. All right. So next up, we move to, we already defined our scope. Now we have to define our activities. What are some of the ways that we can define our activities? One method is same, decomposition. It's a fancy word, but it basically means taking your lowest level WBS and breaking it down into activity levels. So activity levels are different from WBS. Activity levels have durations and they're basically activities. So that is one method. So you know, maybe on a high level, the lowest level WBS, let's say it's you have to erect a scaffold. Okay, so you have to erect a scaffold. So if you decompose it, what you decompose it to, you can decompose it to activities where maybe on the first activity you have the tradesman, the rigger, come and help carry the scaffolding poles. All right, and the second part of it is where after all the scaffolding poles have been brought to site, then the scaffolder can start erecting it. So that's just an example. Basically, this is in major use across all projects. Sometimes we have templates, ready-made templates that you can just use to put your activities. But usually with templates, you still need some modification. Okay. Next, what is the process that we do to define our activities? You need to have a proper activity naming description. So you need to make sure that your description explains action to something. So meaning your verb first and then a noun. For example, you install the verb, equipment is the noun in area A. Okay, and your activity description has to define a single deliverable. And usually we try to make first letter of each word an uppercase and we avoid non-standardized abbreviation. The key word here is standardization. You may have some abbreviation you want to do, but make sure it is well known across the board and it's standardized. Okay, so if you see here, not sure if you can see this, but what we have here is an image that says, how do I ASST-OPS2 VLV2 close posit. So this is what's happening here is the project supervisor on site is with the project manager and they're equally confused. They're looking at the work program schedule and they're saying, why is the activity named like that? I don't even know what that means, right? So for the outsider, they wouldn't know what it means. Probably only the planner is the only one who knows what it means. And I know I have an embarrassing story to tell. This actually came from me. So early on in my career, when I was very green in my career, we had a pilot project where we had to input activity lines, maybe about in the order of 3,000, 4,000 activities into SAP from our Primavera P6. Now, the problem with some of you use at SAP, you know that in the short text field, operation line items can take characters no more than 40 characters. So I had to abbreviate about 4,000 activities down to activity names, maybe down to 40 characters. So I told myself, there's no way I'm going to do this, one by one. So being the smart, so-called smart person that I was, I tried to develop, I knew some programming, so I tried to develop something like this. So I made a database of say, okay, this is the word input and the output is the abbreviation. And, so I made a dictionary and then I ran the program and this is what I put into SAP. And you know what? I got into a lot of trouble over this because to them it was not readable and they were right. It would not be readable by the site team. It would not be readable by anyone. So this was an important lesson to me early on in my project controls career that I should never do anything unilaterally. Two heads are better than one, okay? And you learn that very fast. So I got into a lot of trouble on this, but it's a very important lesson for me, okay? And next up, this is what I would call a proper activity description. So this is a construction project, so tender works program. So under earthworks, we have this ground treatment. So normally the sequence is you cut and dispose, and then you replace the soil, the unsuitable soil. So you can see my activity naming convention, cut to dispose. There's a verb, and then there's a noun. I put the chainage there, and it's consistent, same amount of white space, so it's able to search. Another thing is that it's intelligent. Why? Because let's say I have a lot of activities. If I want to link, let's say, chainage 85,400 and to 85,400, I can just sort the activity name. So I don't need to scroll down and find where is the corresponding chainage 85,400. So this is what I will call intelligent activity naming. Okay. Right. And next up, we have activity sequencing. The CPM uses, what is a CPM? CPM is the critical path method, and it uses a network logic diagram to represent the dependencies on all activities. So usually in the CPM, how we represent it is an activity is represented as a box, let's say activity A. And the predecessors are the activities that must occur before activity A can occur. Successors are the activities that can only occur after A has finished. So the constraints such as events preventing this activity from happening. For example, contractual dates. So they said like this activity has to finish on this date, or it can only start on this date. So these are constraints in our schedule. Or for example, we might have on a construction project, there might be a way leave issue. So way leave issue is when you have the old landowners of a certain land that's in the new road alignment of the new project, and they do not agree to the land being used even after receiving compensation from the government. So this is what we have to build this into the schedule because it's an actual event that will delay our schedule. Okay. What are the relationship types that we have? The most common relationship is finish to start. So activity A must finish before activity B can start. Second, we have start to start, meaning activity B can only start after activity A has started. We also have finish to finish, where activity B can finish only after activity A has finished. And finally, we have start to finish, which is the least common type of relationship types, which is activity B can start only after, well, activity B can finish only after activity A has started. All right, proper planning conventions is your schedule should be utilizing finish start most of the time. As much as possible, it should be utilizing finish to start. And sometimes you might find difficulties to do this. And usually when this happens, you have to start looking at other things like your activity durations. Are they too long? If your activity durations are too long, it's difficult to use a finish to start. And a proper activity will usually not have activity durations more than 40 days. So there's a standard set of guidelines, and our organization also has a set of guidelines. So feel free to contact us and we can provide you with these guidelines. We can also do schedule interrogation to make sure your schedule is complying with all these DCMA 14-point analysis, which is basically the industry standard for determining whether a schedule is up to scratch or not. Okay, and now, what kind of logic do we have? This is important. Sometimes we have the schedule of softwares, new planners and new schedulers, when they're learning the software, yes, they link this activity A to activity B and they call it finish start. And sometimes there has to be a difference between these two. There's construction logic and preferential logic. Construction logic is basically saying, like in this example, if I want to paint a wall, I got to scrape off the old paint. And then I can paint the wall, which is true. There's no way you can paint the wall if you don't scrape off the old paint. Well, you can, but you don't want to do that, okay? So it has to be done. It has to be finished before you paint the wall. So this is what we call hard logic. On the other hand, you have preferential logic. So maybe I have 4 walls in the room, right? So I can paint wall A and then I can paint wall B. So this is preferential logic. Now, it's not wrong to use preferential logic in your work program among your activities, but from my experience, at the bare minimum, construction logic has to be there. So you must have the construction logic, and then you can add preferential logic. Why do we want to add preferential logic? We will come into that later on, but sometimes preferential logic is added to show maybe the scheduler knows how a certain things are going to be done, or he knows that there's not going to be enough resources to do it. But as we will learn later on, preferential logic is not the only way to do resource optimization. Okay. we have relationship lags too when you're doing activity sequencing. So here we have a piled embankment. What do you notice what is piled embankment? So piled embankment is basically a layer of concrete, reinforced concrete across a section of road. And it's usually used for sections of road that have very bad soil. So they need to excavate the soil and do this piled embankment. So you notice here, it's a huge square that needs to be done, this piled embankment, but I've only done one part of it. So as a scheduler, what we think is that, okay, I don't need to complete all my rebar before I can start my concreting, right? So I can complete one section of my rebar first, then I can complete another section, then I can start my concreting works. And while the concreting works is ongoing for that small section, I can continue my rebar works. This is modeled in the work program as legs. In P6, Primavera P6, software that our company primarily uses, you're able to model this. So we know that install rebar is a predecessor to pour concrete, but we know after a certain number of days, we can start pouring the concrete. So we model the start to start plus lag, but we know that there's no way that the concreting can finish after the rebar. I mean, there's no way the rebar can finish after the concrete. So the concrete can only finish after rebar is completed after a certain number of days. So that's why we add a finish to finish plus lag. Okay. This is but what do you see if we see another close competitor of Primavera P6, Microsoft Project? Microsoft Project unfortunately is not able to model this. Why? Because Microsoft Project, you can only have one activities, okay, one relationship between two activities. So I'm not able to model it like this. Okay, why would this be an issue? You say, you say install rebar is always going to complete before pour concrete. Not always. Sometimes when you have a rebar, what do you know about rebar? Rebar is an item that you need to purchase. Sometimes there's a material delivery. The supplier is not able to supply the rebar. So how we model this in our schedule, when we update our schedule, we need to increase the remaining duration to model the delay in the delivery of the rebar. So when we do this, the remaining duration for install rebar becomes longer. But because we had not included the finish plus lag, it turns out that install rebar is going to finish after pour concrete, which we know logically is wrong. Okay, another question you might ask is, well, I mean, maybe some of you seasoned P6 users might be saying, but I use a duration percent complete. So it's always going to be proportional. Well, I would say when we try to model the real world, we use physical percent complete. Because in the real world, delays occur and you need to be able to model this into the work program. And that is what is shown here. And Microsoft Project is unfortunately not able to model this discrepancy. There are workarounds, for example, making a finish start with a negative lag, basically essentially what we call a lead, but it's not advisable. All right. All right, next up, we need to estimate the durations. How do you estimate our activity durations? One, you could use expert judgment. Expert judgment is basically asking someone who has been involved in this field for a long time and he knows what he's doing, asking him how long will this activity take. So I like to think of it as, do you guys know Who Wants to Be a Millionaire? So sometimes in this game, when you're close towards the end, you have an option to ask the expert. So say who's the only US president born in Georgia? Maybe that guy doesn't know. So he decides to ask the expert. So he calls the expert and the expert tells him the answer is Joel Stein. Now you know what the problem with this is. The problem with this is it's not always right. Your expert, your so-called expert might not always be the expert. His experience might only be relevant to one project. Okay. Besides that, this is not a systematic way of estimating your durations. Can you imagine going to this expert and asking him every single activity how long it's going to take? So that's why normally most of the time we'll use something we call parametric estimating. They're actually separate, analogous and parametric estimating. But for this example that I've shown here, it's a combination of both analogous and parametric estimating. So what we have here, we have a method developed by one of the companies to estimate the work done, the man hours that's required for an activity. So if you look here, you have construction norms, meaning historically, these are the man hours that have been recorded for such activities that needs to be done. So this is the analogous part. Analogous meaning that it is the part that is historical. Historically, we know the data, we know how long it will take. So that is the analogous part. Next up is the parametric estimating. Parametric just means that you know something will take this long. So this units, so I'll say maybe if it's more than 4 meters, it's going to take 6.92 man hours. Similarly, if the rating of the piping is, let's say, 600 pounds per square inch, it's going to take 1.8 man hours. So that is parametric estimating. So this most of the time when we estimate our durations, I would say most planners, they use parametric estimating, and rightly so. Although I do have to add that sometimes it's not so much about which is the best method. Sometimes it's also about how much time do you have? What is the situation? Sometimes your client needs to know like by tomorrow, or he needs to know in the next 30 minutes. So, you're on site, you don't have access to your phone, you don't have access to your dictionaries or anything. So you have to try to ask an expert on site. Okay, so it depends a lot on the situation and the timeline that you're given to estimate the durations. We also want to reload our schedules. Okay, so what is the type of labor resource? So we have two types of resources. We have labor resource, which is usually a labor resource is what we call like human beings, and they're typically assigned as a role for tradespeople and a resource name for engineering. And then we also have our non-labor resources. So non-labor resources could comprise materials such as concrete, steel, welding rods, or equipment like cranes, welding machines, scaffolding material, and so on. Okay. And we need to resource load our schedule, but we do this by we're going through a resource management process. So first we define the resources. We already have our activities. Now we need to know what are the resources we need to do those activities. So I go back to the scaffolding activity. I need a rigger on site to help the scaffolder lift up materials, and I need a scaffolder. So those are the two resources that I need for the job. Then I need to assign the resources. So I assign the resources to the scaffolding activity. Next up, I analyze the histogram. So the output of the assigned resources in a software like Primavera P6 able to give you outputs on histograms. So you can analyze this manpower histograms. And that's not the last step. You notice we're missing a step here. We need to determine the availability. This is just as important. The schedule may look very beautiful to you, but it may not work out for the company because for example, they might not have the manpower available to provide that amount of resources that you have stated that you require in the program. So that's why after you've analyzed your histograms, you need to go back to your, let's say, your manpower coordinator, your manning coordinator, or even your project manager, and you need to ask him, this is my histograms, is it doable or not? And it's an iterative process. It'll go back and forth. So they're going to say, yeah, we can do this, but we can't supply this guy for this period. So you need to go back and assign the resources, do your histograms, and go back until everyone is happy with the process. Okay. And finally, once you do your resource loading, you move on into the scheduling phase. So we have the critical path method, and we're going to talk about resource leveling and baselines. So this is a critical path method. It's a process that calculates the longest path of the planned activities to the end of a project and establishes the amount of load each activity has. Okay. So every proper project should have a critical path. Because if it doesn't have a critical path, you're basically telling your project owner that, hey, I can complete my project earlier than you want me to. And as you might imagine, that's not what your project manager probably wants to tell the client. Okay, how will you do CPM? We have our early dates, and this is getting a bit technical, but just bear with me. So we'll perform an early date, which is also called a forward pass, and we'll also do a late date, a backward pass. Okay, and this will give us the outputs will be to give us the critical path and the total float. So I've used an example here. This is a CPM network. All right. So what we have here is this is how we get the CPM. This is how the CPM engine works. So you have 4 activities, A, B, C, D, all with their own duration. So durations in the bottom right. So activity A has 7 days duration. Activity B has 13 days. D and C. I'm not going to go much into calculating this as we are limited on time, but I will show you what the end results are. The purpose of doing this is to show what is our critical path here. All right. So we'll perform an early pass and a forward pass, okay, forward pass and a backward pass on the CPM network. And the output will look like this, all right? So all these numbers will show up, and it's numbers that you can do with your calculator, or you can even do it on your head. So basically what we are looking for, the meat of what we're doing here is the total float. If you look here, this path here has a total float of 12 days. Here's a total float of 0 days, 0 days, 0 days. So total float means the amount of float the activities has in a project before it can delay the entire project. So the critical path method most definitions will be when your total float is equals to 0 days. So here we are easily able to see that the critical path runs from A to B to D, and not from A to C to D, because here the total float is 0, 0, 0. Now, can you imagine, let's say for a work program there's 2,000 activities. Can you imagine doing this calculation for all 2,000 activities? Well, I mean, probably some of your grandparents could, because back in the olden days, this is what they did. They actually drew this out on paper and they did the calculations by themselves, which is why we emphasize the use of Primavera P6. Primavera P6 is a software that will do all these calculations in automatically, and you can rely on a CPM engine. So again, to emphasize, total float is the amount of time an activity can slip from its early date without delaying the project. Okay, so we see here, kickoff method, which sometimes you can represent it on a Gantt chart. So what we have here is you have all these activities here, A, B, C, D, E, G, F, H. And when it's represented on Gantt chart, it looks like this. And the red line that runs through the bars are basically the critical path. So you can see how activity B, activity D, activity E are not on the critical path. So this is an important tool to companies because it allows them to know which activities to focus on. However, there's a danger on this, because if you focus too much on the critical activities, your other near critical activities will themselves become critical. So again, this is the response. This is in the realm of the scheduler and the planner, and it comes down under progress reporting, and we'll go more into that later on. Next up, we also have resource leveling. All right. To optimize the required resources against the available resources to achieve the project deliverables within the contract duration. This goes back to what I talked about earlier on. We have the histogram, but we're not sure if it's workable. So we need to sit down with our manning coordinator, we need to sit down with our project manager and see whether those resources can be achieved. If not, we have to do some resource optimization, such as resource leveling. So there's two types of resource leveling types. One, you can be resource constrained. Another is time constrained. Normally, organizations will use a mix of this, but the final result will be a time constrained resource leveling. Okay, so here I have an example of a resource leveling I've done in P6. This was Standard Works program. As you can see, the red shows that the resources is more than what we have. So it looks pretty bad, right? It looks pretty bad. I don't have a lot of resources for these guys. So what I'm going to do, I'm going to perform some resource leveling. And you can do this in Excel. It's just going to take you maybe 1 year, right? So then I can do it in P6. So what I do resource leveling. I have my settings. Okay, so P6 has this really cool and powerful function to able to level resources. So you can schedule your work program and then you can level your resources. And there are many settings you can use. Like here, I've used a leveling priorities, late start, total float. You can select which kind of resources to level. So look at the shape. Look at the shape of that. So this has turned from a schedule that has been front-loaded to a schedule that has been back-loaded. Sometimes this might not be what your organization wants, but at least for the purpose of this standard work program, it was what my project owner wanted. Okay, it was what my contractor wanted. Why is this important? Look, if you put everything front-loaded, what does that mean to your contractor? It means that he has to have increased his capital outlay because he has to push out all his resources in the beginning of the project, and that's not good cash flow for him. Okay, and if we make it a bit backloaded, it's a bit more easier on your contractor, on your client. All right, and if you notice, it completed all within the same time. This is time constraint, so the project completed within December also. So again, let's look at that. Okay, so see, it completes in December 2023. Sorry. All right, right. See, it still completes at the same date. It's just more backloaded. All right. What we have here is the S-curve. So this you would say is the S-curve representation of the resource leveling that we just did. The curve at the very top is our scheduled. Basically, our scheduled baseline, and it's not resource level. So it's based on activity relationship logic. It's based on constraints. And then what you have at the bottom, most bottom, is your late curve, which is calculated based on your late dates. All right. Now, normally a lot of organizations, they will say, okay, in my S-curve, give me an S-curve report. I want my early and my late. Here at PCSS, we don't recommend using the late at all because for all purposes, for us, the late curve is not relevant. because it's all it's saying is that, okay, I can delay my project up to this date, and then I'm going to pump in all my resources. The problem with that is, how do you know if at this point you're already delayed, and how do you know that in 1 year's time you're able to pump in 3 times the resources? So it's not, it gives a fake feeling of progress to the project owner and everyone involved in the project. Instead, what we normally advocate is to have two curves. You have your early curve and you have your resource leveled curve. Okay, so at the bare minimum, what you're trying to monitor your progress is based on the resource leveled curve, because that is based on you telling the project owner, okay, these are the resources that I can commit to for the entirety of the project, and it's been resource level. And you know what? If I'm able to put in more commitment, I'm able to pump in more resources, and that might make me closer to the early to be able to achieve the early dates. I mean the early curve. All right. So this is the S curve that we're talking about. Now, what we want to say is that sometimes sometimes this curve might not be fully representative of the project. So it's always good to check with your project owners, to check with your clients, what do they think of the S curve. Sometimes they might think it's too steep or not. Okay. I had another point I wanted to bring up, but I've sort of forgotten it. All right. Next up, we move up to baselines. All right. So once you have already had your schedule, you've done your resource leveling, the project owner has signed off on it, they agree with it, you can proceed to develop your baseline and basically create a baseline. All right. So your baseline is used as a benchmark to compare your current progress against to compare current progress against. And what are types of baseline? We can have baseline in terms of your time. So in your Gantt chart, it will show you what are the activities that needs to be that you plan to complete, and what are the current dates of your activities. So you're able to see on a Gantt chart where these activities are positioned to each other, and you can compare them. You can see whether this activity, whether you plan to complete it earlier, and now you see that you've not been able to achieve those dates. Okay. You also have costs. So you can have a cumulative S curve, which is just what we've seen. So we've seen both examples earlier on. And then also we've seen our resource histogram. So these are the baselines that we can monitor our progress against in terms of time, cost, and resources. So here's an example. So the reason why I didn't put an example from P6 here is because it can get quite messy for people who are new to P6. So here we have a simple example in Excel. All right. So here, this yellow line in a planning and scheduling software would basically be your baseline. And those greens will be your current dates. Okay, so right now everything is still as your baseline. But once you start updating the progress, more than likely these things are not going to stay in place. Maybe for this activity, it might move forward a bit, or this activity might move backward a bit in accordance, compared to the baseline dates. Okay, so this is a baseline schedule. Next up, we move up into the controlling phase. Sometimes in some projects, what we do is we just go up to the planning phase. And honestly, that's just one part of the story. The second part of the story is you need to control and monitor your project. You can have the most beautiful S-curve, the most beautiful schedule, but once it goes to site, everything just goes to pieces because you have not been monitoring and controlling it. So this is a very important aspect that I would feel from the technical side, a lot of our players, schedulers and planners are lacking, especially in the construction industry. So I'd like to expound more on this. So first up, we'll go through schedule updating, and then we'll perform performance analysis and reporting, and then we'll see what are some of the project control actions we can do. Okay. So to update our schedule, it means it's a process that's used to update a baseline project schedule so as to reflect its current status and forecast when and at what cost the remaining work will complete. Okay, so this is important, very important information to the project owner. They want to know whether the project will complete on time. In fact, this is one of the most basic questions that's often asked of planners. So when asked a planner, one of the most basic questions it asks, how long will it take to complete this job? And how do you know the answer to that? Well, you need to know what is the productivity rate, and if you know the quantity, you know the duration. So this is the same thing except on a macro scale. All right. So the process that's involved is you need to know what is the status to date. You need to be able to input into the software that you're using, what's the percentage activity complete. You also need to put in actuals. Okay, although not many projects do this, because to them, the contractors, they don't see the benefit of putting in actuals into their work program. Fair enough, but it takes away some of the benefits that would have been provided if they had done this. Another one is also they put in the resource costs and the forecast to complete. And such as this is important. For example, you need to forecast to complete. So an activity that originally you planned that would take 10 days, it might no longer take 10 days. It might take, let's say, now it takes 15 days. Okay, so you can't just ignore, close your eyes and pretend everything is fine. You have to model in your schedule, and now it's going to complete only after it's going to take 15 days to complete. So this will give you the aggregate of this, it will be to give you a forecast to complete, an accurate forecast to complete. Okay. So this is an example that we see here. Okay. So this example of the same baseline schedule that we're looking at, which has been updated. So we can see here this is our data date. So our data date is, I'd say, on the 5th day. Okay, so we started to update our project on the 5th day of the project. So we updated and we've seen this activity is 100%. So this is the data date line. Anything below on the left-hand side of the data date is history, nada. There's nothing about it. It's already in the past. Don't need to worry about it. What you need to focus on is on your right-hand side. Right-hand side is your present, your future, your forecast. So that's what you need to focus on. So once you've updated these activities at 100%, 100%, I would like to put an example here. Here, we originally planned for it to be 2 days. But we see now the forecast completion is not 2 days. It's probably, let's say, 2.5 days. Okay, so there's a reason for that. So this project scheduler has done a good job of modeling the delay inside. He's also done a good job because he put in actuals into the schedule. And because of that, he's able to see not just the earn, he's not able to see just the earn, but he's able to see the actual. And because the earn is basically saying that, okay, originally I planned for this activity to take, to cost this much to complete. And that is your earn. So if I completed 100% of a project that I originally planned to be, let's say 100 ringgit, so I'm only going to earn 100 ringgit. But on actual, I maybe spent 200 ringgit on it. So if the contractor had put in, the planner had put in the actuals in his work program, he would have an accurate forecast to complete. So you can see he's going to complete above budget. Okay, so instead of 6,000, it's going to complete about maybe 7,400. All right, and it's going to complete later than planned. All right, so this is the benefits of updating your schedule. Next, once you update your schedule, you also need to perform analysis and reporting. What is the definition of performance analysis and reporting? It is, let me add these guys. Okay, it is reporting the legitimate divergence from the schedule baseline for us as a decision-making tool. Okay, you know that you're delayed, but what are you going to do about it? And what are the processes that you need to go through? Elements to analyze and report. This is what you need to do. When you have updated your schedule, you need to see what is the effect of any variance of your project status. So variance refers to the difference between your schedule and your current, okay, and your actual. And do you have any contractual milestones that may compromise? Maybe the client said, you need to complete this project by December 2023. But now after updating your schedule, you see that it's only going to complete in February 2024. Okay, so what are you going to do about this? You need to have a catch-up plan. What is the effect of any scheduled date variances? And has the critical path changed? This is important. Okay, maybe the critical path previously was on the bridges. You were delayed on the bridges. So you pump in your manpower, you put in additional teams, you brought in an extra ball piling rig or whatever it takes. And you've done a good job, now that bridges is no longer critical. But don't just rest just yet. You have to check, are there any other activities that may have become the next critical path now that your bridges are no longer critical, all right? So a project scheduler is never really at rest. He always has to monitor his schedule. And finally, has allocated resources been compromised? So this is the reporting process that we use. You have to define the stakeholder requirements in the beginning, and this was done in the beginning. You have to check what do they want to know in the performance report, in the weekly report. This is important because you don't want at the end of the day after you've updated something and then the project owner says, this is not what I wanted, go back and redo it. So at the beginning, you have to standardize the reporting process. Make sure you define the stakeholder requirements. Next up, when you've already updated the progress, don't send it off to the project owner just yet. You need to have an internal discussion with your project team, all right? Or else it may get you in trouble later on. Remember, you are not the only voice in the project. It is the voice of the entire project team. Next, you need to, once you have achieved the internal approval, you need to distribute the progress to the different stakeholders. And most likely you need to present it. And finally, after the presentation, then you decide what are the actions we need to take. These are the problems we know and what are the actions are we going to take. So this is an example of a reporting process flow. So I would say that maybe the client tells us, okay, client won't tell you all of this. It's up to the contractor to manage. But let's say the only information the client tells you is that, okay, I want to review the progress every day, every week on Thursday. Let's say this is a weekly reporting process flow. Normally JKR is monthly, but let's say oil and gas, usually they're on a weekly basis, right? Because the stakes are usually higher. So let's say the client says, I want to review the progress on Thursday. That's all he tells you. So it's up to the contractor, it's up to the project scheduler and planner, the project controls team to devise a reporting process flow. So this is an example of what it may look like. So on Friday morning, the project scheduler will update the quantity measurement sheet. So basically where we've put in the quantities that have been completed, which allows us to aggregate the quantities and convert it to the percentage. All right, so all that's done on Friday morning. So I reset the file and I send it to the focal points. So focal points are basically the site engineers that are responsible for updating the site progress. And I give them from Friday morning until Monday morning to update the progress. Okay, so on Monday morning, they're going to update the progress, or maybe even Saturday. In construction, they work on Saturdays. So they're going to update me in general items as a site engineer for that, civil works, bridges, traffic management, the site QS. So all that information comes out, the output, and is given to me, to the planner. So I'm going to take all this input, all right, and I'm going to take these spreadsheets and these quantities that have been completed. I'm going to convert it into percentage. And when I convert it into percentage, I'm going to put it into Primavera P6. All right. So that is my method. To update the progress. You should have a method to updating the progress. You can't simply say, I think this activity is 50%, 80%. You need to have a basis on it. So in this project, we use the quantities of work done as a basis for the progress. So once I put into P6, I need to reschedule and analyze all the work that I did just now. I need to update, I need to insert the progress. And what do I do after that? Next day, I don't send it off to the project owner right away. I sit down with my project, with the contractor project management team for their concurrence. I present it to them. We have an internal meeting to get the approval. Sometimes they don't agree. Sometimes they think the progress should be higher. Fair enough. So then it's an iterative process. It just goes back and forth. The important thing is you get everyone's approval and incorporate all the comments that was present in the internal meeting. And finally, on Wednesdays, what we do is we can finally submit it to my project manager, contractor project manager. Then he'll review it one last time, and then he'll submit it to the project owner. And then on Thursday, we report. So we attend the meeting and we report the weekly progress. So we use slides, we use anything, and I'll show you later on a bit of what we use. And any analysis that you may want to give to the project owner, which you have decided in the beginning of the project. And during this presentation, that is when you will decide what are the actions to take to resolve this. For example, we know we are delayed on this activity. That's what you reported as a planner. So project owner will say, okay, so what are you going to do about this? So maybe the contractor PM has discussed with his planner and say, okay, this is our mitigation plan. This is our catch-up plan. Project owner says, okay, I accept it. Go ahead and continue doing it. All right. So if you look on the left-hand side, there's a small RESC chart. It's just to emphasize the importance of communication. Sometimes in a big project, roles can get a bit mixed up. So sometimes you may find the need to use this RESC. So RESC basically means responsible, accountable, supportive, consulted, and informed. Like in here, responsible for deciding the actions to take would be the project owner. Who's supporting him is a planner, and accountable, of course, would be the contractor PM. Okay. So sometimes you may not need to use this, but sometimes in your organization, you may need to have this clearly set out so everyone knows their roles and responsibilities. Okay. And a typical schedule reporting could consist of like look aheads in Gantt charts, critical path, and the resource histogram and the performance S-curve. And as I've shown previously, all these can be extracted from Primavera P6. And I would like to say, be creative with your progress reporting. If you have really talented people in your organizations, you can always use them to show, find better, more granular ways of reporting the progress updates to your project owner. Sometimes just showing them a Gantt chart won't do it. Sometimes what wows them or what allows them to have eyes on site are videos like this. So in the PCSS, we train our staff. So what we have here, we have one of our existing staff is Yan. So he is being trained to use this UAV Phantom 4. So it's a drone technology, and we've been using it for quite some time. So we use this to capture site progress, because this is a little different than, let's say, industries like oil and gas, where the project location is just confined to to a platform, to a fixed platform. But here in construction projects, we have projects with chainages that range maybe 80 kilometers. So there's no way you're going to take pictures of all these things. So another way, one of the faster way we do is we take drone videos along the entire chainage. So this is an example of what you can do to be creative. Okay. So this also was done by one of our talented engineers, Mr. Amar, and the bridge structure was done by our intern. Okay, so you're able to combine the 3D model with the drone video, and you can show them, all right, this is our actual, and that was our plan. So this sort of gives an idea. This also gives an idea to the project owner where we are on the progress, and it's very visual. And we're actually going to talk more about this because PCSS, we are also one of the resellers of one of the leading software Synchro 4D in the market. So you might have heard of the building information modeling methodology, and it's currently in place in Singapore or neighboring countries, and it's picking up in Malaysia. So do tune in to our Synchro course also. It I think will be sometime in the next 2 weeks. So do follow us on that. All right. And finally, once you have shown all the progress, the reporting to your project owners, they need to take some actions. For example, what are the actions we can take? Okay, one of the ways we can see is, okay, there's nothing we can do. We just have to accept the project will take longer to complete. For example, MCO, we have this MCO ongoing now. We can't do any work. Maybe not so for offshore, but construction, we are not able to work for at least 2 months. So what this means is that, most likely it would lead to claims, extension of time claims and all that. And it's a known fact that the project will take longer to complete. It's just that it's not being contractually agreed on. Okay, sometimes to complete the job faster, you might need to work overtime, and then you might have to change resources. You might have subcontractors that are not performing. And sometimes when your subcontractors are not performing, this is also the role of the project controls team. You need to have a log of your subcontractors of their performance. You need to write letters to them to say, hey, you're not performing, write the first letter, second letter, third letter. And if you continue to underperform, you might need to make the drastic action of changing your resources. So make sure all this is handled as early on, even in the contractual phase when you draft out the contracts, all right? You also will need to add resources to complete on time, or you might need to reduce the scope, phase the deliverable. So this is quite common, let's say in offshore work program schedules. So, but I might say, okay, this work order number can't be done during this turnaround, so we have to schedule to the next turnaround. So, you're still going to do the scope, you're just not going to do it in this project. So that means you're reducing the scope and you're phasing it to a different part. And then you can also delay other work. Maybe some work that's not as critical as the ones that are critical, you can delay them. There's 2 methods that's normally known for making sure you try to complete on time. One is called fast tracking. So generally this means the schedulers tries to find which activities can be performed in parallel. So you think about it, activities that can be performed in parallel, it generally means you can complete the project faster. Sometimes you have to be careful about this because some activities cannot be performed in parallel. Another way to make sure you finish on time is by crashing the project. Crashing means you're just putting more resources into it, and you still want to complete as per your contractual completion dates, and you're going to do whatever necessary. So that usually means like scheduling all your activities towards the end and increasing all your resources. Okay. So I think that is the end of my session, and I really thank you guys. I think we're over by 5 minutes, considering we're planning to have the Q&A session. So if you have any question and answers, I will pass it over to the MC. So over to you, Flora. Okay, 2 hands. Oh, all right.
Okay, all the participants, please feel free to ask any question and answer.
Okay, so you can also paste anything in the chat box or anything, and we'll get back to you. We'll have your contact details. We can also email the responses back to you.
For the next session, we do have an introduction to P6 webinar on 29th of May,
Mm-hmm.
the same time like today, 2:30 until 4 p.m. So if you
Mm-hmm.
haven't registered, feel free to register and join us. And then
Okay.
following of that session, we have PMP webinar on the 5th of June, the same time as today also. So during the PMP webinar, we do invite one of PMP trainer to join us for that session.
Mm-hmm. Thanks, Flora, for the outline of the upcoming courses. So we are hosting quite a few webinars, so feel free to join us and follow us on website so you have updates to the latest notifications. Now, going through the chat, I see probably about I see a question here from okay. I think she wants to be anonymous. Okay, she says that hi, may we know how you usually get the historical data for duration activity calculation? Is it manually recorded or you have some good approach in doing so? Okay, I can speak from my experience in two industries. In the oil and gas industry, usually the oil and gas industry is considered one of the more industries that are fast to adopt uh, approaches. So I'd say they're fast to adopt the approaches of construction norms. And because it's high stakes in oil and gas industries, so they have a very established set of construction norms already available. You can find it online on the net. Okay, so these construction norms have been calculated by historical records. It's based on historical records from multiple activities. Maybe what in the past they did is they went to the fabrication yard and they literally took a stopwatch and they start activity starts. Okay, finish, they stop the stopwatch and they record all this down. And the end result is what we have as a handbook, construction norm handbook, which we are able to use in the oil and gas industry. No, that's not to say that it is perfect. Definitely, we are looking, we always think about continuous improvement. We know that with new technological advances, certain construction norms, let's say it takes me 4 man hours to do a bolt tensioning, for a certain pipe size. And then maybe now with a new bolt tensioning technology. So in there, 4 hours it may take me 2 hours. So that means the construction norm in the handbook is no longer relevant. So that's why it's important for organizations, even though they have access to this kind of data, it's also important for them to have a reviewing process of the construction norm. And this data should come from their own self. So there should be a department, maybe the KPI department in the company, that records down the actual man hours that's produced of these activities. And this is the value of that. So when you put in this actual man hours and you record it down, you can perform some statistical analysis and you can try to come up with the revised construction norms and then get everyone's approval and put it into your work program. It's for the benefit of everyone. Now, for the construction industry, unfortunately, it's not as advanced as the oil and gas industry in terms of the availability of construction norms. So I would say construction projects, the planners, they have probably to get the ball rolling. They have to pitch the idea to the project manager, to the company, of the importance of starting to record down the actual man hours spent. It goes beyond just KPI monitoring. It goes beyond just monitoring the efficiency of your workers. It's for the future benefit where you're able to estimate activity durations a lot better. Okay. Um, Kai, Kai, are you there? Okay, because I see a question based on synchro. I'll try to answer that. It's also, hi, may I know in synchro, which is the 4D BIM software that I mentioned, may I know in synchro, as mentioned in the slide, we need to define all the schedule scope, but when we do, the pre-construction item is included. That is, can synchro reschedule,
Yeah, hello.
especially, oh
Yes.
yes, okay, Kai, would you like to answer this question? Okay, are
Oh
you
yeah,
able?
I have answered it.
Okay.
Yes, you can do what you call it, define a scope through synchro, but the method is different. because as you know, if you add WBS in Synchro, it's like you're adding an activity or task in Synchro. So it's not as systematic as Primavera P6 for set. But that's why, like I said, Synchro is also can be a complement software to Primavera P6, where you can integrate schedule from Primavera P6 into Synchro, and then if you want to sync it both way, you can do it also. Okay, and then the second question is that can we synchro reschedule, especially when we deal with logic loop linking activity? So like I said, synchro, some of the feature is the same as Primavera P6. So when you have a logic logic relationship that is looping, then it will not do the scheduling. It will prompt you a error message that you need to fix the linking first before you can do the reschedule of the project schedule. Right?
Okay. All right. So I think maybe time's up. So Flora, back over to you. Oh, I see another question. Okay, last question. Hi, man hours and duration. What is the best way, in your opinion, on determining the weightage on the activity? Okay. There are a few ways to do this. I'll speak on behalf of the construction industry. So in the construction industry, man hours and duration. Okay. So I'll say in the construction industry, what we do is we base it on the work done, the weightage is based on the cost. So it's based on the cost of the activity. So in that activity, if it's cost, okay. So okay, so we'll continue. So if in a work program schedule, in your activity you have is cost loaded, so the cost comes with a bill of quantities. So that will determine the weightage, because that cost can be compared to the overall. It can be compared to the overall cost of the project. So that will be what will determine the weightage on the activity. So when we do progress updating, we update based on the quantity. So if it's achieved the bill of quantities, we will put it into our spreadsheet, and that spreadsheet will convert it to percentage, which is basically just reflecting the cost of it. And that will allow us to put in the, give the corresponding, the percentage, activity percentage complete corresponding to the weightage. Okay. All right. Hope that answers everyone. Okay, I think.
Hi, Bian, can you share, can you make Flora as a host right now?
I'm sorry about that. Okay.
Okay, there's a participant is asking about our social media. So basically, this is our Facebook, Twitter, Instagram, and LinkedIn for you to follow, so that you can get the up-to-date information for any free webinar and online training that we organize after this session. So thank you. Okay, Bian, you can continue.
Okay, I think that brings us to the end of this webinar. Again, I really appreciate you guys taking your time off this afternoon, and let us all stay safe in this period, and do keep a watch out for our upcoming webinars. Thank you. Bye.
Bye, thank you.